Oh, hello there. I see you're here to learn a little bit about, oh yes, gravity. Well, you've come to the right place. Over here. That's better. People call me Frank. Frank, the free-falling fruit. Let's start off with the Earth, shall we? Gravity is the force that pulls us to the Earth and the Earth to us. However, the Earth is made up of a much larger amount of stuff than us, more matter, or as the sciencey types like to say, more mass. Because of this, our world does most of the pulling, which keeps us firmly on the ground. Okay, so we know Earth pulls us down, but now the question is, how quickly are we being pulled? Well, there's a very simple way to test this. We can fall. Oh, I know it sounds a bit silly, we're gonna forget that air exists. Just go with it, I'll explain it. Geronimo! Hold up there a moment. Now, when we started off, we were up there, and we had no downward speed. We've now been falling for a second, and have a speed of 9.8 meters per second. Over time, our speed is changing, or, in other words, we're accelerating. We carry on speeding up, but the rate at which we speed up stays the same, at 9.8 meters per second, and we can write that like this, but it's easier to write and say meters per second squared, and this number is what we call acceleration due to gravity, roughly. Everything, whether you're an apple, a leaf, a toaster, or anything else, falls at the same rate as the Earth's surface, no matter how heavy it is. That is, when air isn't involved. So you're probably desperate to ask by now, but Frank, what about when air is involved? An excellent question, but to answer it, we're first going to have to look more carefully at what air is. So, I got us some air, and here it is. As you might have guessed, doesn't look like much is occurring. But if we zoom in a bit, actually it's still pretty much the same thing. But if we zoom in some more, yeah, okay, nothing again. If we actually want to see what air is, we'll have to zoom in much, much more than that. So let's go. Ah, here we are, the atomic level. See those things whizzing around? That's air. In reality, there are lots and lots of different types of molecules and atoms jumping around to make air. But for what I'm trying to show, we'll just call them air particles. Now, when a certain apple falls through air due to the Earth's gravity, there are bound to be many collisions with the air particles on the way down. Each one pushes with a tiny force straight upwards and to the right and left, which together combine to create a force that resists the force of gravity pulling you down. This is known as air resistance, or drag. So in real life, when a leaf is falling, its large underside is constantly being hit by air particles, causing it to sway unpredictably, rather than dropping steadily like me. Thanks for watching, see you next time.